Welcome to IoT Asia. Today we come to an exciting forum on the topics of overcoming complexity of IoT interoperability. I'm sure we all know that the IoT is very exciting, but yet at the same time, it is also complex with the mixture of sensors, network, platform, software, vendors, projects, and so forth. And so how do we get each to work together as a one platform, and how do we get them to interoperate? So today we have with us a panel of very distinguished speakers to discuss on this topic. All right, first and foremost, let me introduce the speakers. Our first speaker is Mr. Quek Yang Boon. He's a big man. He's the director of the Smart Nation System and Solution Sensors and Internet of Things from GovTech Singapore. So I'm sure he will come with lots of experience to share with regard how Singapore as a smart nation tackle the issue of IoT. Next, we have Mr. Carl Weaver, who have a nice Chinese name called Wei Kara. He is from Ethos.io, and he's the Global Business Development Director. And certainly he also does have a lot of experience to share. Third, we have Christophe Bedolfer, who is the Connected Technologies Evangelist of Arista Corporation. All right. And last but not least, we have Mr. William Tan from Backhoff Automation. So with it, you can see that we have a wide panel with speakers from different fields who can share with us different experience. All right, let's get on to it. All right, the first questions we're going to ask ourselves is, okay, since we talk about IoT interoperability, okay, how do the speakers see it, and how do we currently stand? So first and foremost, allow me to ask Mr. Quek Yang Boon, since coming from the user standpoint in Singapore government, he will have a lot of experience to share.
Oh yes, IoT interoperability is always a big challenge that we always have to tackle, and I think the scenario is not something that is trivial to resolve, because if you think about it, the reason for it is because every company, there's so many companies, and IoT is so diverse. Many of them are specialized more in hardware. Even on hardware, there are different types of hardware. There can be environmental sensors, there can be robots, there can be actuators for factories, and it's very, very diverse. So how do you try, what do you mean by interoperability then? So we have to try to piece it out into categories. Like for example, if you talk about certain use cases, certain applications, then let's try to achieve some interoperability in at least that domain. Say for example, let's say a smart home. All right, so let's try to handle just a smart home alone. But even then, because of the multiple companies like Google, Apple does some, Amazon does some, and for proprietary and profit reasons, they do not share their standards. And that is where a lot of the issues happen. Yeah, so it is something that I think will continue. And it is a challenge that we have to try to tackle. And on my side, how I tackle it is, at least I don't deal with like global interoperability. I don't deal with even the industry. I only handle and focus just on the Singapore government. Let's try to at least get within the Singapore government, whole government, let's try to ensure that at least for the same domain of applications, we can achieve some level of interoperability. Thank you.
Thank you. Shall we hear from Christophe?
Yeah, thank you. Yeah, good points. And I think one thing to add as well is technology, in our view, in my view, goes through multiple cycles of iteration usually, right? And if you look in the past, it's always been very similar cycles. Initially, a new technology starts as innovation. After a while, the innovation turns into the services phase where it's being produced as a service. And then at the end, it transforms into a commodity phase where everything is being continuously commoditized. The example that I always make is with cars. You know, cars in the beginning of the 19th century, 20th century, were an innovation. And then they became a service. They were like custom-made cars, and now they are almost a commodity. So we can look at, for example, IoT devices as well. You know, in the beginning, there's innovation, and everyone has their own standards. Everyone uses their own things. But then over time, they will turn into, or they are already like a service thing where you hire a company to to implement IoT, but then in the future it will be very commoditized. So people can buy off-the-shelf solutions that will need to be able to interoperate very easily. Now, during this there's a land grab phase of each of the companies at the beginning, where they try to grab a lot of land by kind of creating their own standards. But at some point, the companies will have to open the gates and start to become interoperable, because if let's take an example of Apple. If they impose their standards, at some point they would have to make refrigerators or pocket calculators or whatever, but they don't do this kind of stuff. So there needs to be a point where they go like, okay, let's just open and let's just kind of start kind of working together. And that's kind of the floodgate moment that we are about to, I feel that we are about to see, especially in home with Matter, for example. So this is one of the things that I feel.
Thank you. I'm sure William has something to share from Pokov.
Yes. So I can speak from the perspective of the industrial automation world. So in this industrial automation world, starting from around 2015, automation manufacturers have started to put IoT capabilities inside controllers, PLCs, and PACs. These are otherwise very traditional devices, which are meant to control the machines or processes in the factory. Now they can also be categorized as IoT device. So when it comes to interoperability of those devices, a lot of manufacturers adopted initially a shotgun approach, support everything and as many protocols as possible and see which ones will stick. So interoperability between these devices are actually critical to achieve the next evolution of manufacturing, which is part of Industry 4.0. So luckily today, most of these IoT devices are converging into a single interoperability platform or standard called the OPC UA. So also known as the IEC 62541. So this is the current state, what I see in my industry currently. Thank you.
Thank you. Can we ask Wei Carl Simpson to share more?
Yeah, so thank you. So we can summarize this then, because I think all of my previous speakers did a fantastic job explaining the interoperability issues. I see it as device, network, and platform interoperability problems. They're all there. But my company focuses also on the connectivity side of IoT devices. As you know, an IoT device always has some kind of connectivity, cellular connectivity. And within that space, if you're going to have connectivity and if you're going to have data come from the edge of sensor collection, then you need the security. That's very, very critical. How do you get that security? Well, you need a secure enclave in the device. Are there secure enclaves, or is the security enough for the data in these devices? Hell no. Okay. So the other issue is the connectivity of the IoT devices, which is where my company mostly focuses. So devices made by different manufacturers cannot integrate together. There are standards for connectivity. It's 4G, it's 5G, it's LoRaWAN, it's NB-IoT, et cetera, but within those flavors, there's no interoperability within those different silos of connectivity solutions. That's kind of my answer.
Thank you. So interesting perspective. Perhaps I think the audience will be very interested to hear some real experience and project you've done. So something that you get your hands dirty. So what are some of the big challenges? So shall we ask Mr. Quek, Yang Boon, to share again?
Yeah, sure. Yeah, well, working on the Smart Nation has exposed me to personally, giving me the opportunity to personally drive a lot of these very exciting projects. So I think one good example will be a smart office that we are trying to build. It ties in a larger picture more like a smart facility management kind of thing for whole government, which is important because there are more than 140 agencies in Singapore, and each of them have their own physical offices, right? And we always talk about, oh, how can we smarten them and make them more productive and also maybe look cooler. But at the end of the day, as a government, you want to then connect all these officers and kind of manage them holistically. The issue now is all the agencies kind of operate as like independent companies, right? And they all then call their own tenders. And then what happened is you have, say, give me just example, like HDB, they have their own smart office implemented by vendor A. Then they have another, then let's say BCA or even GovTech might have a different vendor implementing. At the end of the day, we run into the same problem where all the vendors then do not talk to each other. But there is an important need for them to be connected, because we do implement whole government solutions, like say a room booking system, right, for whole government. We want to also maybe even allow different government officials to be able to enter different government buildings. But if they are not connected and you want to implement, say, facial recognition so that you can recognize us and let us go in, you then need all this smart technology to somehow be able to work with each other and interoperate. So that's where we run into a lot of these challenges. Over.
Thank you. How about Carl? Have anything to share on your side? Real life experience?
Yeah, actually, I'm kind of intrigued. What kind of technology are you using to go from building to building? I'm thinking near field communications or something with Bluetooth. I'm wondering how you do that in GovTech. Very interesting.
Yeah. No, right now it's very much low tech. You still use a batch system. So yeah, but there are thoughts about, you know, for example, right, my team actually designed and implemented the Trace Together token. So
great.
yeah,
yes.
So
Fantastic.
that, you know, it is reasonable, logical to think that if the government is issuing a token is a secure way of identification, right? Why couldn't we use the token, since it's built by and designed by the government, to enter government buildings, right? And that's where you run into all these interoperability issues. By the way, the token is also a highly secure device. I think it's our first embedded system in the whole country to actually receive the Cybersecurity Agency level 4 rating. It's the highest in the nation. Just to let you know, since I know you are the cyber guy. Okay, yeah. Sorry to interrupt.
That's very interesting, because we are going to, through our organization Wanchang Blockchain, we are going to work on the Penghu Digital District for the integration of IoT and blockchain. It leads me to the question, the second question, which is experiences. We are implementing IoT with blockchain. That's what we're doing. And I know that in Singapore, some people still have this view that blockchain is nothing but cryptocurrency, but that's not the fact. Blockchain in itself is very critical. Anyway, my company worked on our first proof of concept, which was quite interesting in that we worked with a Telefonica of Spain to prove the proof of concept to integrate IoT with blockchain. But in itself, there are interoperability issues. The great thing about that was that Telefonica had their own blockchain platform. They call it Trust OS. And this is all public information. That's why I can reveal it here. And they also have a DID, a decentralized identity element of their Trust OS operating system. So I'm just sharing a little bit of that. Thank goodness that they had their own blockchain platform, and of course they have their own IoT modules. Had it been different, and had I been talking to another mobile network operator who might say, oh, just go and find the platform for a proof of concept. Oh my goodness, because there are lots of blockchain platforms out there. And of course, there are lots of cellular IoT module manufacturers out there. There's definitely going to be an interoperability compatibility issue, even though we have software that integrates one to the other. So just wanted to relay that kind of very simple project explanation. And we're hoping to move forward with that in 2022 as well with Telefonica. That's all I wanted to share.
I think, Yongbun, just I also have an interesting a question to ask. I mean, if you have multiple building, multiple agency, multiple systems for a smart facility, it's going to be very complex because of many existing systems already in place, and the current system don't work to each other. So will GovTech take an approach of one kind of unified system to address all agency, or will GovTech take a kind of a platform approach whereby it is a standard platform and a different kind of application or sensors or network may come on board into this platform so they can interoperate? So what approach will GovTech take?
Yeah, it will be more of a platform approach that you mentioned. That one actually I will elaborate more, I think, in the next question, I think. yeah.
Since you, we are all very interested to listen.
Yeah. If you want, I can go ahead and explain now.
Yeah, Jonathan doesn't want to let that one go because that's a very interesting question.
Yeah. No, so the way I tackle this, right? I believe that if you really want interoperability, you need to have one, like what Christopher has actually mentioned, you need to have one leader to drive it. Like Apple has, let's say Apple is going to drive it, Apple has to say, I do it. Then in the end, you have to release your standards. You have to then provide the technical know-how, the training and all this for other people. You need to be someone that is so-called selfless, willing to help to drive this thing. And it is more so in the government, right? Because we are a non-profit and we really want to do it just for the good of the country, which is why since GovTech and Sensor IoT, we are taking on the role of being this driver. And so we built this platform, which is called DICADA. DICADA actually is a short form that means for device control and data management. So what we do is we say, okay, let's have this device management and data management platform for whole government, and it is on an open. It's kind of like open source. We provide the open APIs. We provide the open standards protocols for connecting to, like, say, OPC UA and QTT and all this, or even we even provide the embedded hardware capability and the platform. So the idea is, in order for you to implement your IoT system, right, in the government, you have to adhere to 200 or 300 pages long of IM8 requirements, security requirements, government compliance requirements. And it usually costs a lot of money, a lot of headaches for our vendors to implement that. What we are trying to do is we take this chunk and say, focus on your capability, right? Which is what kind of sensors you want to use. What is the physical environment? What is the use case that you're trying to do? Focus on the other layer, the top layer, which is the application, right? How do you interact with your own agency, users, and all this? But as far as the IoT device and data management, the security, the reliability, the robustness, right? Leave it to us, the engineers, to manage it for you. And so we then provide it this way. And we are trying to and we are encouraging all the government agencies, right? If you call a tender, go ahead and call your tender and do what you want. But we will come in and help you, we'll consult, and we'll help you craft out what is the middle part that you will want your vendor to write on. So if you think about it, at least for the government, if all the agencies, they are all on DICADA, right? Or regardless of what application they are, whether it's environmental, smart office, a smart gym, all of them, all the sensors and all the data are all managed and by this DICADA, and it's managed by my team, right? Which we have the knowledge. If you want us to interoperate, right? Okay, nothing is trivial, but at least we have the knowledge to do it. The engineers are here to implement it and allow them to all connect to each other, and they are all on the same platform. So even if the data format is different, we can, if there's a need to connect them, we have ways to say, okay, let's translate this data format. Even if the protocol is different, we can do that. So that is how we tackle this issue. And so far, we have seen quite a lot of success in DICADA. We have about 5 to 10 agencies already on board. We are already managing hundreds of thousands of, tens of thousands, hundreds of thousands of sensors. That is not including the trace together tokens, which we have issued almost 10 million of them. And they are all managed by DICADA. So it is a reliable and robust platform that we are building to help the government to ensure interoperability. Yeah. All right.
Quick question. Had you looked at UWB as a solution, because Samsung and Apple smartphones have I think they have a grand strategy for UWB. And I wonder if you looked at that technology as well.
Yeah, UWB as an ultra wideband, right? Yeah, it is.
Yeah.
So this is so you got to understand Dicada is agnostic to the network or the connections protocol. So it can be Bluetooth, Bluetooth mesh. It can be just even a wired LAN connection. It can be Wi-Fi. It can be 4G and network.
Anything.
So what we are doing, which I think you can relate more, is actually for IoT, right? Is actually the 5 device management lifecycle, right? So first you have to plan what it is, and so on. But I think the main thing technically is how do you authenticate and ensure every single device is what you want, right? So that nobody can come in and just throw in their device and connect to your system. So authentication of this, of course, is very highly secure. Then after you connect and all this, right, you implement the system, how do you then securely connect to the cloud device management system and ensure that the data is encrypted the way you want and be able to send it correctly? So this is pretty much how it is. Then after that, when the lifecycle move on, then it's things like how do you commission it, how do you decommission it, how do you do a firmware upgrade securely, right? So this is the main, that's how I look at the main gist of IoT management. And interoperability just means, you know, how do I ensure that this bunch of data from this company and these devices can somehow see or talk to this bunch of devices from a different company if I have to, right? If they're all connected to the same management device, then there is always a path. But if they are two silos, then they will never talk to each other. So that's the whole idea. Yeah. So things like, so that's why we are agnostic to things like, say, what is the hardware platform you want? But although we do provide a platform to facilitate, but not to mandate. Say you can use a Raspberry Pi, you can use the Intel gateway if you want. You can even use a computer if you want to, right? And then when it comes to the connect, the communications network and all this, it can be anything. If you want, you can route wires if you want. You know, the idea is after you are connected, how do you manage them securely? That's the whole idea behind it. Yeah.
Thank you very much.
Okay, thank you, Yong Boon. That's comprehensive. A lot of people will be really interested to hear for the deep experience that run through. Can we also hear from other speaker? Let's hear from Christoph, if how you deal with some of the past issues or project you have.
Exactly. The way that Kwek Yang Boon described it is exactly the right way, I think, forward. What you do is you split basically the whole setup into multiple layers, where you have, for example, the frequency layer, the hardware layer, the communication layer, and the application layer, and so forth. And there will be always a bridge between the different ones that kind of are shared one thing in common. And for example, one of the projects that we recently got involved is, a factory monitoring system, for example. They would want to use LoRa for certain reasons, but our system doesn't necessarily support LoRa. But what we can do is we can use the MQTT function of our system of Gravio, which is our IoT edge computing system, to use this as a combined layer with the LoRaWAN implementation, and this works very smoothly. But there is some challenges with that as well, because there are certain expectations of certain technologies, such as, for example, service level agreements and things like that. So the expectations and everything have to be managed very carefully. So so the customers know that, for example, LoRaWAN might have a different kind of service level than, for example, the Zigbee-based sensors. Because the way that the protocols work and as such. But I think the key is that you have a platform like Gravio, or like the project that you described earlier, that can kind of split it up into multiple layers and then find the layers that connect to each other efficiently and manage the devices accordingly.
Thank you. How about William? Can you share about experience and how you tackle?
Yep. So my company did a project together with Symtech a couple of years back to realize the model factory So this is a showcase where the production floor is highly integrated to the IT system, where the data from each machine is harvested and shown on the dashboard. Right, the machines inside the production floor are also communicating between each other, transferring valuable information like the products being worked on and so forth. All of them are communicating via this OPC UA standard. Coming up with this OPC UA solution was actually the biggest challenge back then. So the questions being thrown about how do we transmit the data and what information between the devices, do we write a new protocol or do we build a new platform? So do we use existing ones, but which ones? So this project also involved multiple vendors, international vendors as well. And surprisingly, when OPC UA was proposed, all the vendors agreed. There was also one European vendor inside the mix. They are a machine maker. And when we asked them, hey, do you have something with this protocol platform? And they said, well, yeah, we are designing our next generation machines based on the OPC UA, which is wonderful. Huh? So now information can then flow between the devices in the factory floor. And among these devices will then be connected into the edge device, and the edge device into the cloud of Symtech. They were communicating with MQTT. So there was a mix of those protocols inside. And this is how we finally tackle all these interoperability issues among each other. Yeah.
Carl, you have anything to share?
Well, I was going to just tackle the third question. Should I move on to that?
Yes, we're talking about the second and the third question together.
Yeah, so there's actually a fragmentation for the IoT industry, because the IoT industry, everyone likes to talk about sensors, but sensors are simply things that are put on the IoT device in order to register, and there's a you're registering something, you're measuring something, but it's the actual IoT module which is the key to the IoT industry. And a lot of people don't realize that. It's the module, because that's what provides the sensors combined with the connectivity and, of course, the security. Now, we see it as being incredibly fragmented. How have we tried to overcome that interoperability issue? It's very simple. There are only about 15 cellular IoT module manufacturers in the world, okay? And then they can also support many different protocols, but there are only about 15 of them in the world. What we've done is we've partnered with 9 of them, and we've created an IoT alliance, because that's the only way. Of course, for us, we're doing it for our purposes as a company to use our technology. But I think it's very, very important to have an alliance of vendors all at least communicating with each other. And that's a difficult thing when you're talking about 9 different competitors, but we've created an IoT alliance, which is actually very important, but we do it for the modules, but that's because it complements the technology, because our technology is embedded into the modules. But I also wanted to just quickly mention something called the identity of things. We believe that the IoT module is the perfect vehicle to create the identity of things from the IoT device into the blockchain. So, but we've actually done a lot to help solve the fragmentation and the interoperability of these IoT modules.
Yeah, thank you. I think as I hear all the 4 speakers, of course, I would say the reality of things is it shows that IoT interoperability is still a very complex issue, and it's actually far from achieving it. Carl will talk about, I think, more within the SIM-based world specifically than at the module level. William is more at the industrial automations, and so where the protocol is largely OPC kind of environment. Yang Boon, being in GovTech, will I would say have the widest complexity, because all sort of sensors, all sort of network, so also application comes in, and Yang Boon then try to solve it by having, right, when there's no standard, sorry, right, it's a bit noisy. When there's no standard, you create your own standard on the CADA. So it looked like it's far from achieving the dream world all in one, right? So given such kind of, I would say, cowboy land that we are in, all right. So I think each of us here have our own perspective of how to do things, all right. What do you think, moving ahead, what can the industry do in the area of standards, in the area of commercial technical framework, or even government regulation that may be necessary to enhance interoperability? Or what can the industry do, right, in the absence of such interoperability standards? What can we do to make it better? All right, I think there is already some answer along the way. Perhaps this will be the last question, and can everybody sort of summarize? Let's start with Yang Boon.
Yeah, I don't think there's a good answer for this, but I think I think that that's why I focus on the government, because the industry is too big a monster to deal with. So no, I think okay, there are really some efforts, at least from the government entity side, right? Like Enterprise Singapore, they do try to set some standards, but nobody actually has the real how to say it, ability to say this is the standard, you have to follow it. Nobody has that power to do it. Simply because you think about it, Singapore is so small. Who are we to tell the industry giants like Apple and Google what standard to use, right? So I feel that for me, I do it by doing baby steps. So for the industry, I will also recommend the same thing, right? I mean, industry, you do it by baby steps, like what actually my fellow panelists have also suggested is like they try to form some alliance, try to identify certain niche domains and areas and applications that you will and try to then identify a few big players and come together and say, why don't we try to allow our devices and all this to talk to each other? You establish the channels. There is no, I personally do not believe that you can create a piece of document, publish it on the internet, and all the IoT devices in the world will start talking to each other seamlessly. No such thing, right? I mean, it has to have a central body to be able to allow some of this to talk to each other. For example, let me give you an example. You know, like WhatsApp works for all the phones, right? Be it Android or iOS, be it whatever brand, right? It works, but it has to be managed by WhatsApp. You need to have a company called WhatsApp to manage all these technical interoperability, or rather protocol devices and all, so that to be able to make sure that it talks to the different phones and all this. So you still need to have a central body to kind of still have the technical know-how, the resources, technical engineering resources to ensure that, hey, if company A and B wants to talk to each other, can I look at it and then look at it on the broad picture and try to ensure that on the big basis they can talk to each other. So that's how I view it. Yeah, thank you.
Christoph?
I think, well, to a certain degree, I disagree with Mr. Yang Boon to a certain degree, because the question is, is there a central body that will have to, to control everything, or will it kind of gravitate towards standard almost automatically, like organically, and there will be something like a task force on the internet, like the Internet Task Force or Request for Comments or the ERC standards, for example, in Ethereum, where people get together, and it's not kind of necessarily organized by a company, but it's kind of by people that share the same interests, or by bodies that share the same interest, and then kind of standards will emerge from that. And they are driven by the common least, the most frictionless way of doing things, right? People tend, or companies tend, to go towards, the path of the least resistance. So this could be kind of coming more like a federated system that kind of organizes itself. I think a lot of it will be influenced by the way, for example, that the IP protocol is working, or that certain blockchain protocols are working and things like that. So that's why, for example, we at Gravio, we focus heavily on, let's say, TCP/IP based communication and things like that, because we feel that this is probably where this all will gravitate to. You can even see it in some of the new emerging projects. You know, a lot of it is kind of IP based in the future going forward. So there can be some flexibility within that, but it's very kind of well known and established, and it's a small resistance way of doing things at the moment. So that's kind of more my belief. I feel, but yeah, let's see. It's definitely exciting in the industry for sure.
Thank you, Carl. You.
Okay, going back to, as I mentioned before, the concept of the identity of things. You know, actually, IoT devices were not designed to communicate with via humans. They're really machine to machine. That's why the whole term M2M, that's where it came about. And we think that IoT devices need trusted data ownership in order to have successful interoperability. We're helping to solve that problem. We also believe that there is a scientific way, and there's a scientific means. We call it consensus in the blockchain world. We believe there's a scientific means in order to get that data trusted to help the interoperability. And we're, our technology is on 9 cellular IoT modules right now, and we're shooting for all of them. We think that we can help to solve the interoperability issue by using the blockchain. We believe that the marriage of 2 different technologies will help solve the interoperability, will also help solve the problem of trusted data of all these IoT devices. That's the whole focus of what my company is trying to do.
Thank you, William.
Yes, from the industrial automation perspective, it's a mix of Christoph and Yang Bun's answers, right? So in industrial automation, still there's this threat of fragmentation of protocols, of platforms, of communications among the devices. And I think the biggest step forward, right, is to get everybody to talk, right? All the stakeholders, right? So we are talking about the makers, the system integrators, the users, right? Get them to sit down, to talk, to discuss their needs and their concerns, their future plans in their projects. And on the other side, getting someone from the standards body, right? Like in this case, in the automation industry, this is OPC Foundation, right? To listen to all these concerns and needs and cater to them, right? This is a critical step, and this is what my company Backoff actually believe also, and this is why we supports all the open standards, right? Especially like OPC UA and MQTT, right? So we try to prevent the fragmentations from happening, even though it's going to happen more or less. Try to minimize it, right? So that's my quick take.
Thank you all the speakers for sharing how you approach it. I realized I didn't share about my own company. I would just a quick one, not to self-promote, but we actually do IoT sensors and network. We have deployed 1.3 million sensors around the world in tracking, in metering, smart building, and so forth. So our approach is actually quite similar to Yang Bun's approach in that we know that there's nothing, it doesn't all talks. So the only way to get things to interoperate is to create a platform to actually read all the different kind of network, be it LoRa, be it Sigfox, Bluetooth, Wi-Fi, NB-LT, and LTE-M, right, across the LTPN world. And all the sensors were a different way of reading, and we had to read the binary data and so forth, and then translate it and map it into a simple to read API, which the application layer can read off. And so if I quote, we can't change the world, but at least we can change how things can be run. And so far, the platform has been stable and collecting data for millions of sensors every day. So that's the approach. So how the industry will evolve, we really can't tell. We can't tell everyone what to do. And also to share, I'm also in the IMDA IoT Technical Committee, of which Yang Bun was once came into chair, of which IMDA invited various agencies from GovTech, HDB, STE, and Savannah Jurong, and quite a number to come down and share how they approach it. And right now, the committee is in the process to define a Singapore standards, all right, that can be then applied. So we look forward to a good result a year later, all right. Because so let's hope we do not. So as the government evolve with certain standards, and the industry may come out with certain standard or de facto standards. All right, I think it remains to be seen, but eventually I'm sure like the IP world, things will eventually come on ground together. All right, anyone have any last thing to share? Just to be, no, that's all. So thank you so much everyone for joining us in this exciting time to discuss about IoT, and we do look forward to sharing with everyone in the next session again. Thank you so much. Bye-bye.